Here in lesson 46, we're going to learn about triangle similarity for three different categories. The first one we're going to talk about is angle similarity. We haven't talked about this one before. Let me show you an example of a triangle with angle similarity, and then it wants us to walk through a proof in example 1. We're going to show that triangle I think that's a C, ACB is similar to triangle DCE. So what has been given is AB and DE are parallel. We have a parallel signs right here. So what can we do to prove that these have angle similarity? Well, we already know actually that angle C is in both triangles, and it's the same thing. So if I drew both of them, triangle or angle C would be congruent to itself, and that would be reflexive property. I'm going to abbreviate. So now we know that one angle is congruent in both triangles. Well, the next thing we know is, since we have parallel lines, that's given, we actually know that E is equal to or congruent to angle B. So angle E is congruent to B. Why? Well, because of corresponding angles. Since we have parallel lines, we know that these are corresponding angles. If I drew it out here and made it look like that, you would see that these two angles are the same, corresponding. And so then you could say the triangles ABC is congruent to triangle DEC because of angle similarity. Now you may wonder why don't you need the third angle? Well, the reason this angle is assumed to be congruent is because if you have two angles in a triangle, and you know, whoa, almost tripped, and you know both angles are the same, well, let's call this one 50 and this one 60. There's only one answer for that third angle. So if we have angle, that would also be the same as angle similarity. But that's just another similarity theorem. The next one is side. Let's put it as the second one. Side similarity. And it's exactly as it sounds, and we've kind of done this before. Side is where all the sides in the polygons are proportional. So here we have, I would actually need to flip this triangle to make it look the same. So I'm going to go ahead and flip it so you can see it better. It'd be Z, this would be X, and this would be Y. YX is 6, this is 12, this is 9. Now that I've flipped it and reorganized it, we can see the triangles a little bit easier. And we can compare 4 over 12. So that's a 1:3 ratio. And let's see if it is the same as others. 3 over 9. That's also a 1:3 ratio. Let's check the last one. 2 over 6. Also a 1:3 ratio. So since they're all the same ratio, we know that they're proportional and the triangles are similar, but it is known because of side similarity. One more triangle similarity theorem is angle side. So this one we have this triangle with all this extra stuff in it. I'm not going to write the whole proof out. I'm simply going to kind of state why it's side angle side, because I think you get the idea. Well, both of these, let's look at the first side. This one has one congruent side to the other. So I could say EY is my first side. But then notice that EF is a combination of EY and the extra that is already congruent to the other side. So EY plus YF is actually going to be the same as EX plus XD because they have the same measure. So those sides are congruent, and we know that angle E is congruent because it's the same angle in both. This is a triangle here, it's got angle E, and this is a triangle here that also has angle E. So therefore, that would be side angle side. If I wrote the proof out, it would be more structured and whatnot. But that is just an example of side angle side similarity. Remember, similar is same shape, different size. These are both triangles, same degrees for the measures of the angles. However, the side lengths are different size. One's bigger than the other, which is okay. They can still be similar. But that is all that we're going to actually look at in lesson 46.